This lesson will review the law of sines and how it can be used to solve a triangle that has no right angle in it. I will also discuss when to use the law of sines on the ACT College Entrance Exam. So let's go to the classroom to discuss the law of sines. Okay, let's talk about law of sines. First of all, you're going to be dealing with a triangle that has no right angle in it. So let me draw one. And I'm also going to draw the sides opposite. If this is angle A, the side opposite, I'm going to do a lowercase a. Same thing with B. I'm going to put a lowercase b, and the angle side opposite the angle C, lowercase c. Now the law of sines goes like this. Sine of angle A over the side opposite, lowercase a, is equal to sine of angle B over the side opposite, lowercase b, equals sine of angle C over the side opposite, lowercase c. That's the relationship of those using sines. Now, one thing you need to keep in mind, when can I use the law of sines to solve a triangle that doesn't have a right angle in it? So I'm going to write that down. It's a key thing to know. You must have an angle and the length of the side opposite of it. So it must have the angle and the length of the side opposite of it. So let me give you a situation that would illustrate that. Still have A, B, and C here. And I'm going to give you angle B. I'm going to write that as 100 degrees. I'm going to give you angle C. I'm going to tell you that's 30 degrees. And I'm going to give you the side opposite the 30 degrees. I'm going to give you a length of 20. Notice I gave you an angle and a side opposite of it. That's crucial. That's when it's going to be a giveaway when to use law of sines. So you can actually start writing your ratios up here. You can write sine of angle A. Oh, let's find angle A real quick. Now, if remember, the interior angle sum of a triangle is 180 degrees. So we can add these two. That would be 100 plus 30. That's 130. Subtract that from 180. We got 50 degrees here. So we can write relationship. We would have sine of 50 degrees over, and I'm going to call this little a, side opposite, so I'm going to put little a over it, equals, and then we could say that's got to equal to sine of angle B, which is 100 degrees, over its side opposite, which we don't know. I'm going to put a lowercase b there, and that's got to equal to sine of angle C, which is 30 degrees, over its length, which is 20. See, what you're going to notice is one of these ratios you're going to have top and bottom. You need to have that, otherwise you cannot solve for the other missing parts. You can create a proportion, a couple different proportions. We can find A and B now. So we can start by taking the sine of 50 degrees over A equals sine of 30 degrees over 20. You got 3 of the 4 missing parts, and if you remember how to solve a proportion, you cross multiply, so let's go ahead and do that. You're going to get A sine of 30 degrees is equal to 20 sine of 50 degrees. To solve for A, you're going to have to divide both sides by sine of 30 degrees, so let's go ahead and do that. So you're going to get A equals 20 sine 50 degrees all over sine of 30 degrees. And if you do the math, you got to use your calculator for this one. So when I did that, let's see, what did I get? I got A is equal to 30.6. Now let's go ahead and solve for b. Now we're going to take the ratio we got right here, sine of 100 is equal over b is equal to sine of 30. So I'm going to write that over here on the side. Sine 100 degrees over b is equal to sine of 30 degrees over 20. Cross multiply to solve for b. So you're going to get b times sine of 30 degrees is equal to 20 times the sine of 100 degrees. Divide both sides by sine of 30 to get b by itself. So you're going to get b equals 20 sine of 100 degrees over sine of 30 degrees. Take your handy dandy calculator. Please don't forget, make sure your calculator's in degrees. And if you did the math, you're going to get 39.4 for that measure. Okay, now let's take another situation and what they could possibly do with it. I'm going to use kind of like the same numbers, but give you a different setup. I'm going to give you triangle ABC. I'm going to give you B is 100 degrees still. I'm going to give you the length of AB is still 20. And I'm going to give you the length of AC is 39.4. And say you're asked to find angle C. Say you need to find the angle measure of C. Well, you're going to take the relationship of the angle measure given and the side opposite. So it's going to be sine of 100 degrees over 39.4 is equal to the sine of C over 20. Here, once notice again, you were given an angle measure and the side opposite. That's when you're going to know you have to use law of sines, when you can use it. So, again, we're going to cross multiply. So we're going to get 39.4 times the sine of C is equal to 20 times the sine of 100 degrees. Now to solve for sine of C, first of all, you've got to divide both sides by 39.4. So let's do that. So you're going to get sine of C equals 20 sine of 100 degrees divided by 39.4. So you're going to get sine of C equals, and you can take your calculator and do that math. And when I did that, I got 1/2 or 0.5. Now, that's not telling you what angle C is. That's sine of angle C is equal to 1/2. So what you have to do is take the sine inverse of both sides. So it's going to give you C equals sine inverse of 0.5, 0.5. Enter that into your calculator, sine inverse of 1/2, and it's going to tell you that's 30 degrees. So you could be asked to find an angle measure. So I want to make sure you know how to do that. It just depends on what you're given. But in order to use law of sines, don't forget, an angle with a side opposite's length must be given.